Now we're going to look at a proof that uses your double angle identities. So remember, with a proof or verifying, you're trying to take the more complex side of the equation and transform it into the simpler side of the equation using your identities and your math operations. So obviously this side is more complex because it's a fraction. I want to turn this into sine 2x. Okay, this is also like saying sine 2 theta. So I know that that's one of my double angle identities. If I look at that formula, I know that that is equivalent to 2 sine x cosine x. So if we can change this side into 2 sine x cosine x, we'll pretty much have our double angle identity. So let's think about what we can do over here to transform this. I want to get rid of the fraction right off the bat. So what I'll probably do is change my tangent and my secant into sines and cosines. And to do that, I also may bring this 2 out front. So I'm going to put the 2 out there. Tangent, remember, is sine over cosine. And secant is 1 over cosine. So this will be 1 over cosine squared since it was secant squared. And my justification for that would be a quotient identity for the numerator. And for the denominator, that's a reciprocal identity. So quotient and reciprocal IDs. All right, and then whenever you're dividing two fractions, remember that you can always flip the denominator and multiply. So I'm going to do that next. I'm going to keep this 2 out front. Sine over cosine, let me just write that down. We'll keep that one the way it is. But now I'm going to flip my denominator and multiply by the reciprocal. And that can be your justification, just multiply by the reciprocal. Okay, now that I have it set up like that, I can see that I have some cosines in my numerator and a cosine in my denominator, so I can do some canceling. This cosine down here will cancel one of these cosines, so essentially it takes the square away. So now I'm left with 2 sine x cosine x. I'm just going to put cancel because we canceled factors. And now I have the identity I need. Remember that 2 sine x cosine x is really sine 2x. And my justification here would be I used a double angle identity right there at the end to transform that into sine 2x. So a proof that looked like it may have been a little bit difficult was actually not too bad with those double angle identities.